Hello, this is Camille Fairborn from Michigan State University, and I'd like to welcome you to the inaugural webinar in our new CAUSE sponsored webinar series, where we highlight resources for teaching from our CAUSE sponsors. Contributions from our sponsors support CAUSE efforts to kickstart new educational projects, provide registration grants for CAUSE events, support CAUSE educational competitions, and fund the CAUSE resource collection, keeping our valuable educational resource free and available for all statistics educators. For today's webinar, I'm pleased to introduce Kevin Potcner, who works in the Academic Programs Division of JMP's Statistical Discovery Software. He will give a presentation entitled JMP Data Visualization, an Essential Component of Data Analyses. The way the webinars work is that all listeners are muted during the webinar. You can ask questions at any time by typing them into the questions box, and we'll be sure to ask those questions towards the end and give Kevin a chance to respond. You can also use the chat box if you're having any technical issues. At this point, I'll turn things over to our presenter. Kevin, go ahead.
Okay, thanks Camille. Thanks everyone for taking time out of your day to attend this session. So what we're going to do is I'm going to analyze a data set in the JMP software, and sort of the theme that I want to get across in doing this is that these analyses always sort of come with some type of visualization, the way you're looking at the data, the way you're exploring the data, the way you might communicate results to an audience or colleagues or coworkers, and showing you kind of how easy that is, and it's sort of just essential. And with JMP, all that visualization sort of comes along with almost everything you do, and you'll see how that's key, not just for analyzing data, but teaching students. It's a little bit different than sort of working inside of a programming environment where, sure, you run a lot of analyses, but there's not a lot of visualization often in sort of like an environment, say like R or something. So you'll see how interactive and visual JMP is. Okay, so I'm going to analyze this one data set, and this is a data set that deals with a collection of athletes. There's 31 athletes in this data set, and you see I've got their name. I actually have a little image of who they are, which is going to be fun because I'm going to incorporate that when we start looking at graphs. And the key variable for analysis is this variable oxygen uptake. So we've got a measure of oxygen uptake. And then we have a whole collection of potential explanatory or predictor variables that we, for the purpose of the analysis, want to see how they may be related to oxygen uptake. Are they useful for describing or predicting oxygen uptake? Okay. So if you're not familiar with JMP, super interactive, easy to follow environment. We've got list of variables that are in our data set, list of rows. Over here on the top left are scripts that I've already run, but I'm going to be running these from scratch, but I have them already saved there, and I'm going to show you how you save that. I'm actually going to do one thing here, turn that off. I want to show you actually how I did that. Okay. So one of the great things you can do with JMP is you can color code these variables so that when you make graphs, you'll see that in that output. And so I'm going to pull up this little tool here, color or mark by columns. And what I can do is I can select a variable or a column. So for example, gender. And then what JMP will automatically do is color, in this case, the females red and the males blue. So as we make graphs, that will always be present, which is really great because we can sort of look at differences between those two genders. But you can even do this with continuous variables. So I'm just going to click on one here, age, and so you'll see how it can color code it from light to dark according to that value. And so I can even do that if I want. So again, as I'm making different graphs, the data will be color coded in some scheme that, again, just helps with analyzing data and helps with communicating results. Now I'm going to use gender, just this categorical variable. So when I hit OK, you'll see over here on the left, all the females have a little red dot and all the males have a blue dot. And again, when we do different analyses, you will see that. Okay, the first thing that I like to do when I have a data set, it's sort of good advice for almost anyone, is let's just get an overall set of plots for this data just so we can see what's there. Now, it's not a big data set, there's only 31 rows, so it's not hard to kind of look at this, but you can imagine a much bigger data set. The visualizing data right off the bat is kind of key. So JMP has this really great platform called distribution right under the Analyze menu. And when I launch this, here's the platform, and I'm going to put variables into different roles, we call them. So I'm going to grab all of these variables, oxygen uptake, all the way to max pulse. I drag them into this Y role, the outcome variable role. I hit OK, and JMP will pop up sort of this summary analysis of all these variables I put in there. So if it's a continuous variable like oxygen uptake, you'll see a histogram, you got a box plot, you've got a bunch of summary statistics, and you can change these, by the way. If you plop down a red triangle, I can pull up a little option here where I can pick what I want to see in those summary statistics, or change the confidence level, but I'm going to just leave it as the default. Now, if the variable is categorical like gender, you'll see a different set of output, which is a bar chart and some counts and percentages of the different categories. So this is a quick way I can just get a view of the data, get a sense of, what range are these data values, a little sense of variation, central location. I can sort of look to see if there's any outliers, unusual observations. And another really great thing you can do in JMP is I can highlight data, and when I do that, you'll see that it gets highlighted everywhere in all the other graphs, and also you can see behind the output in the data table as well. So it's a way to sort of select data, and if I want, I can select data that way and set it aside or hide it and exclude it from analyses if I want. Now, for a categorical variable like this gender, if I can click on female, I can see where all of those female values are across all those other variables, back to male. So it's a really convenient way to sort of interact across multiple graphs if I want. Now, you might point out that, oh, maybe these two are some outliers, unusual observations. Yeah, worth thinking about, but I don't think anything too extreme to want to take out from further analyses. Now, you might have noticed when I floated that cursor over that point, so that one right there, it's person's name is Donna. She got an oxygen uptake of 60, and because I added these pictures as a variable in my data table, then that's going to come up. I can choose to have that come up as a label, so as I float over those points, I can see that. And that's just fun. You can think of different data sets that might have an image that goes along with it that is kind of useful to explore. And I think this is kind of a fun one because we've just got people, and we can put a little image of her. We can have that as a photograph. I just happen to have it as a little icon illustration. Now, when you do an analysis like this, if you want to save it to this data table, I can click on this red triangle and I can save this script to the data table. And then if I close it, so I put this here. Now I already have this already saved, so I'm not going to do it. But when I have saved it and close it, then whenever I want to see it again, I just launch it. And there is the output again. Now, if you're in a sort of basic statistics class teaching inferential statistics like hypothesis testing and confidence intervals, well, you'll notice here that we've got the confidence interval comes out as default, and I mentioned you can change the confidence level if you want. But if you drop down this little red triangle next to the output, you'll see a whole bunch of options, which would be, let's say, the next step in analysis. Okay, maybe I want to show a CDF plot. Maybe I want to do a hypothesis test on the mean or hypothesis test on the standard deviation. And I don't know what specific topics you're teaching in your classes, but if you're teaching, say, quality tools, you might want to get into things like a capability analysis. I can fit different distributions. So the way JMP works is the analyses kind of unfold. You pull up a platform, like in this case, distribution. you run the analysis, and then you go from there to do something next, like, oh, I want to run a t-test to test the mean, and you open up that platform, and then you can put in this information. And so I'm just gonna make something up here. And so let's say the hypothesis of interest is to test if the population mean is 55. Click OK, and then added right over here to the right of this distribution output for oxygen uptake, now I have the results of the t-test testing if the population mean is 55 or not. Now you'll notice there's a little red triangle next to that. So if I click on that, options are going to pull up that are relative to what I might want to see here. This one I really like, this p-value animation, because if you're teaching, hold on here, grab, oh, I pulled that way over to the side here. So I can start dragging around sort of that hypothesized distribution, and I can sort of teach students this concept of what a p-value is by sort of sliding this around where I can see the hypothesized mean and the accompanying distribution, as well as the sample mean that I got for this data set. So this is a nice little interactive way to teach what a p-value is. We also have one if you're interested in teaching power. And so same thing here, I'm gonna rescale this a little bit so it's easier to see it all. And I can move it around and teach these concepts of power, right? And type 2 error just from these little animations here. So really great way for teaching. And JMP is filled with these little tools like this that sort of, it just take it out of the analysis per se and get it into a way to teach a concept. Okay. Now, as I said, the main point of this analysis is we're going to see if these other variables like gender, age, weight, run time, run pulse, rest pulse, max pulse, if they are useful at describing and explaining oxygen uptake. So I'm going to close this, and now I'm going to open up a platform that's going to help me start looking at that relationship. So I'm going to open up JMP's graph builder. And the way you make graphs in JMP, I think this is really neat. As opposed to ahead of time trying to figure out what graph you want to make, you pull up this graph builder and think of this as this sort of empty canvas that you start building the graph you want. So oxygen uptake is the outcome or response variable, so I'm going to drag that and I put that on the y-axis. Now, right now, JMP's like, okay, well, you only have one variable, so I'm just going to give you a little individual value plot of that data. I can make it a box plot if I want. I can remove the points and only look at a box plot. Okay. Now, once I bring in another variable, so for example, I'm going to bring in gender and drop it on the x-axis. Now, JMP says, okay, well, you must want to see those two genders as different groups. And here you're seeing that coloring that we set up at the beginning where the females are in red and the males are in blue. Okay, now we have other variables we want to look at, not just gender, right? We have age and weight, and etc. Well, this I think is really neat in JMP. Instead of having to make another graph and then make another graph and then make another graph, what we can do is we can pull up this little tool called the column switcher. And what I'm going to do is I'm going to swap out that variable gender with all of the others. And so now what I can do is over here on the left, I can start clicking between them. I'm going to hit the play button, just let it rotate, moving a little fast. I'm going to slow it down a little bit. So now this lets me swap out the X variable, what's on the X axis, and I could sort of quickly scroll through these graphs. And now again, we don't have a massive data set here, but you can imagine if you have many, many variables, how powerful this is that I can just swap out and see. And if you do this, you can start to see some that have a strong relationship, like runtime here. And if I want, I can add information like R squared or the equation or the results of an F test. So if you're teaching that in a statistics class, you can add some of that numerical information if you want there. And as I click through, you'll see that that information, the equation, the R squared changes as I move through. So just from this, we're starting to kind of get a sense of variables that might have a strong relationship and those that do not. Now I can still interact with this graph. Right now what's happening is it's building one equation for the relationship between each variable and oxygen uptake without regard to the gender. So if I want to sort of have a separate relationship for both genders, I can grab this and decide how do I want to display this. Maybe I want to display it side to side like that, or maybe I want to view it this way. Maybe I want to put the two equations on top of each other like this. I can even do, if I put it down here in page, then what it will do is it'll make a separate graph for each. And as you build graphs, if that's not what you want, you can just grab that variable that I dropped there in that roll page and then move it to where I want to see it, right? So I'm like, oh, that's where I want it. So once you now have the graph you like, aha, this is the one I want. Now I can hit done. I can save this to the data table, the script, and whenever I want to see it, I can launch it. Now remember, as I'm switching through these variables that I'm swapping out on the X, now I have it one for each gender, okay? So this is great, again, not just for exploring data, but I think for teaching, it's really great because that's sort of what you want students to see. You want to change something like a variable and then watch what changes or doesn't change in some kind of output that you're displaying. Okay, so I'm going to close this. And again, I already have this saved, so whenever I want to see it, I can just launch it or close it because I've got it saved to the data table. Now, I like to plot data in as many ways as possible because I think that's just where you see information and, again, teaching concepts to students. So I'm going to pull up this platform called Multivariate, and I'm going to put in all of the continuous variables here in the Y roll. And I have gender already colored, so it's that's going to come along for the ride. So I'm going to hit OK. And now what I'm going to get is all the correlations up here and a scatter plot of all those possible pairwise combinations. And I can make this bigger if I want. This was a nice thing about JMP. Almost in every window, even inside of the dialog box for the platform, you can sort of resize things, make them bigger, smaller, so you can see everything. You can collapse output if you don't want to see it, open it back up. Now remember these red triangles that I keep on pointing out, this allows me to see what options would be available here. So for example, if I want to shut off that density ellipse and only show the points, I can shut that off. If I want to say, put a simple linear regression equation on the graphs, I could do that and see all those. Now this top one right here, this top row, this is where oxygen uptake is on the y-axis, and then I have those 6 different continuous variables going across the x, and then the color of the gender, the male, female here, red, blue is shown. So again, every time you do an analysis in JMP, you'll see this little red triangle, and under there is where options will appear relative to that specific piece of output, okay? So again, we already saw this when looking at that graph builder platform where we started to see variables that might have a strong relationship like runtime. That's this window right here that looks to be the strongest. Okay. Now again, as I said, I like to plot data in as many different ways as possible just to see information and when I'm teaching. So another graph that I often like to look at is, well, let's look at the data in a multi-dimensional way. And so here's a 3D scatter plot that I can rotate around. And again, I got the 2 genders as different colors there. And again, it's great for teaching because you can sort of explore this data, look at it, try to make the data come alive for students, right? You get bogged down with just the equations and the formulas. You know, we know this, we see this. It can sort of, you know, make the subject a little bit boring for intro students. And I think when students can see the data and interact and play around with the data, I think it really helps them see how exciting this can be. And I can just, instead of making another 3D scatter plot for all combinations of 3 variables, I can sort of just click through them, okay? And again, see different kind of relationships, see some unusual observations. So I can just move through all these different combinations if I want. And this is a way maybe to explore outliers in a multi-dimensional sense, not just two variables. Now I can see if they're unusual in 3 dimensions. Okay, I'm going to close this. Now, if you are teaching, let's say, linear regression or one-way ANOVA, you need a little bit more output than what I've shown so far through the graph builder and sort of that multivariate plot. Well, I can launch JMP's Fit Y by X platform. Okay? Now, what's nice about this platform is the students just have to know what variable is the output or outcome variable and which variable are the explanatory predictor variables, and just dragging them into those roles. So oxygen uptake is the Y, and each one of these is going to be a possible predictor or explanatory variable, and so I'm going to drag those in the X roles. Now, this isn't doing a multiple linear regression. That's a different platform. This one is doing just one variable at a time, but this lets me run them all together from one launch of the platform. Now, JMP instantly recognizes which variables are continuous and which variables are categorical. So it's going to know what output. Is it a one-way ANOVA? Is it a simple linear regression? Is it a binary logistic regression? Is it a contingency table? It will know that and give you the output corresponding to that. Okay, so remember, we have a bunch of possible explanatory variables: gender, age, weight, and so on. And so the first thing JMP does is makes a graph of those relationships, right? That's kind of what you want to see first anyway. You don't just want the ANOVA table or the statistical output. You want to see the data. And JMP thinks like that and wants you to think like that. Now, under each red triangle is going to be options related to that particular analysis. So if I have a categorical X, like this gender, female, male, if I hit this drop down, I'm going to get things that correspond to doing a one-way analysis of variance, or in this case, a t-test, because I've just got 2 categories. So I'm going to launch the means ANOVA, and what gets added right below that graph is all the familiar output that you're used to seeing in a one-way ANOVA. So if you're teaching this, and again, if you want to hide things, you can kind of collapse it. So maybe you just want to show the analysis of variance table, you can do that, or any of the other outputs you want. So again, this just kind of cleans it up a little bit. If I go under the red triangle for a continuous X variable, you'll see that these are different options. Well, those are going to correspond to things that you would do in a simple linear regression. So there I just added the classic linear regression output for oxygen uptake versus age. And under here, I'm going to see things you might want to do next, like, oh, maybe I want to plot the residuals, or save the residuals, or add confidence bounds on the graph. So I'm just going to click plot residuals, and then now you see added right below this original graph, I got the linear equation, simple linear regression output, and now I've got all my residual graphs. Okay? And again, if you want to keep the work, your little output here clean, you can sort of expand and collapse those tables. Okay. Now I'm going to actually do this for all of them at once. So I just was able to select it under one, and I hit the command key, and JMP knew, like, okay, let's do that linear regression output for everything. So that's why I just got all this added for everything. Now I'm going to show you one thing here, but I'm going to just close this up just so we can, just so there's only one candidate X variable on the screen, and it's this runtime. It's the one that I thought we saw from the graphs. Looks like it has the strongest output, has the highest R squared. So the strongest relationship has the highest R squared. Okay. Now, what I'm about to show you, you can do this everywhere inside of JMP. Graph, statistical output. I'm going to pull up this thing called the local data filter. And what this is going to allow me to do is I can select variables like, let's see, gender, add. I can select other continuous variables, and then I can start filtering the data and seeing how that changes. Now, what I'm going to do this in here is I am going to, let's see, I'm going to keep this a little simple here. So all right. Okay, so I'm going to add gender, and I'm going to add also a continuous variable, let's say age, add. Okay, so right now, so here's just the statistical output for oxygen uptake by runtime, the standard simple linear regression. I'm going to put those residuals back there so you can see all this output. Now, again, I think the best way to teach a concept in statistics is to change something and then watch what does or doesn't change in some other piece of output. So I can come over here, play with this local data filter, for example, switch between females and males, and notice all of the output is changing, not just the graph, the equation, the ANOVA table, the residual plots down here are changing, everything's changing, p-values, and not only can I do this with a categorical variable, but I can do this with the continuous variable. So let's say you were trying to teach the students like, hey, let's see if that relationship between runtime and oxygen uptake, let's see how that changes for different age groups. Well, I can come over here and I can drag this and start filtering the data, and notice how some of the data is disappearing. And again, all of the output is changing, residual graphs, ANOVA table, equation, and I can say, let's see how this relationship looks just for the people that are over 50. I can even say people who are over 50, oops, sorry. Made that a little small, apologize. I can switch over. I can look at how does that relationship look for young people. And again, I can keep on adding other variables if I want and constantly subset the data and watch how everything's changing. So not only do I think that's a great way to analyze data, just as a data analyst, you want to explore data like that and watch how things are changing. I mean, what a great way to teach a concept and watch to show people if an equation changes as some other variable might be changing. Yeah. All right. Now there's so much I can show. I can start getting into to multiple linear regression and the entire platform within JMP where we fit. It's called fit model, and this is where I can fit a multiple linear regression model. So not just one variable, but many variables. I can put in interactions, quadratic effects, and all of that. And I launched this larger platform. However, we like to keep these presentations in this webinar series to just a half an hour so that we have some time, a little 10-15 minutes to open it up to some questions and discussion. So I'm going to leave it here, but what I do want to point you to is if you go to jump.com teach, let me drag this over here. So if you go to jump.com teach, this is going to send you to the academics section of our website. And inside of here, there's all sorts of resources that you can have access to. Webinars, recorded series, we've got learning library of little quick how-to videos, case study, course materials. So if you want to learn more or point your students to information so you don't have to spend time in your class sort of teaching them how to use JMP, you can point them to some of these resources and say, okay, here's this webinar library we have, and you want to tell your students, hey, next week we're going to talk about, data summary and analysis, and we've got this great webinar on the website that you can go and watch. And so we have all of this content and information. So apologize, we got to keep this one short, but it's the structure of this. But I encourage you to go to all of our learning resources so you can learn quite a bit more than what I was able to just show today. Okay, so Camille, if you want to join back in and help facilitate some conversations and questions and discussions, please go ahead.
Well, thank you very much, first of all, for this presentation and for being our inaugural webinar presenter. If any of the attendees, any of you who are attending today, have some questions, please go ahead and type them in the question box right now, and we'll let Kevin respond to those. As I was sitting here listening, I know probably the first question you usually get is, what is the cost to students for this kind of access?
Yes, so I'm actually showing JMP Student Edition right here. And if you get in contact with me afterwards, I can get you in touch with the right resource at JMP so we can get you JMP Student Edition. And there's a handful of ways. A lot of publishers will bundle it with a book. And so if you get in contact with me on a case-by-case basis, I can sort of direct you to the right way to get JMP Student Edition. Now, I don't know what schools all the attendees are from, but a lot of schools have not just JMP Student Edition, but they actually have the entire JMP suite, which is JMP Student Edition, JMP, and JMP Pro, and then that's accessible to all faculty, all the students, all the researchers. And so if you get in touch with me as well, I can let you know if your school already has it, and then if you're interested, I can get you in touch with the right person that can outline the different licensing options for you. What I should do, Camille, if I send you my email, you'd be able to distribute it to the attendees, and so they can get in touch
Yes.
with me.
Do you have it on your slide that you had up at the beginning?
I don't, but I can actually, you know what? Maybe it's just as easy if I do that right now. I'll show it right now.
Take us the slide right now.
Yeah, hold on. Let me pull that right up. Oh, there it is right there. Okay.
Yeah. Okay. So there's Kevin's contact information if you want to get in touch with him. It doesn't look like we have any questions from the audience today. So again, I want to thank you for presenting, and thanks to all of our attendees for attending today's webinar. Our next Cause Teaching and Learning webinar will be on Tuesday, October 8th at 4 p.m. Eastern Time, not at the usual 2 p.m. Kevin Comiskey from West Point will be presenting on the topic Causal Inference in Introductory Statistics Courses, Why, What, and How. And so I hope you'll be able to join us then. One last time, again, thank you to Kevin Potcner and to JMP for this presentation today. And I hope you all have a very nice rest of your day and week. And we'll see you next time.
Okay, thank you, everyone. Thanks, Camille.